Good morning to everyone. Today we are going to see about the unit number 5, optical sources and photodetectors. The optical sources, it is used to convert electrical energy into optical energy. It is also called as a transducer. The popularly used optical sources are LED and laser. Here, this is an requirements of an optical sources, compact in size, highly directional. So only we have to prefer the laser as an optical sources in majority of the long distance communication. And high electrical and optical conversion efficiency, low level attenuation, minimum dispersion, high modulation capacity, long life, cheap and reliable. These are all the requirements whenever we are designing the optical sources. Next, we are going to see about the intrinsic and extrinsic material. Intrinsic and extrinsic semiconductor, because of basically we want to design LED, so we are moving to R the semiconductor basics. Perfect material containing there is no impurities. Intrinsic material. Pure semiconductor contain no impurities. Intrinsic semiconductor, electron hole pair by the thermal vibration. In intrinsic material also we can generate energy by creating a thermal vibration. Next, extrinsic. The conductivity is low in intrinsic, so we can add the impurities. So this type of impurity materials is called as an extrinsic semiconductor. We can add a donor impurity. It means that group 5, what it is mean that we are adding group 5 electrons. It means that electron is larger than the holes. Outermost orbit, we are have a 5 number of valence band electrons available in the donor impurity. This type of semiconductor material is called as an n-type material because of here electrons are in the majority. And next one is an acceptor impurity. It means that group 3 valence electrons is in the outermost cell. Here holes is in the larger than the electrons. So this type of semiconducting material is, it is nothing but an B-type material, P-type material. Here holes are the majority carrier, and we can consider Nd and N are the donor and acceptor concentration. This is an N-type material. Here is in the valence band, and here is in the conduction band. Here there is no energy. It means that we can have a valence band and conduction band. Here we are EF, it is in Fermi level. Here between the valence band and conduction band, distance is in forbidden band. Here ED is nothing but a donor energy level. Here the area is in higher level because of the electron have a n-type material is in higher, so electron concentration having a higher area. And in n-type material, P holes is also having in a very less one. So we have to represent in a whole concentrations in a smaller one. The same diagram we have to find out in the P-type material. Here is a conduction valence band, and here is a conduction band. Here the Fermi level. Here the acceptor energy level is in near to the valence band. So here the whole concentration is in a higher one compared to the electron concentration. This is a material, P-type material and N-type material. In generally we are have holes is in the P-type material, and electrons are higher in the N-type material. And next one is a direct band gap material. Here we are have a valence band and we are have a conduction band. Here in nearby the hole, automatically the photon energy is released in terms of h nu. This is a direct band gap material. Here from the diagram, here the momentum of k here is here. and the electron is here. So we have provided the external energy to find out the material. So this is an energy band gap in the indirect band gap material. This is in some of the semiconductor material we are going to use in the LED design and laser design. Gallium arsenide phosphide is provided in a red color or yellow color designing. Gallium phosphide produces in red color or yellow color. Gallium nitrate is in blue color. Gallium arsenide is in blue color. And gallium arsenide, it may be an infrared, it is an invisible light. This is an LED construction. One type of P substrate we are going to take, and N substrate we are going to take. And this is a metal conduct, this is a cathode end, this is an anode end. Whenever we are placing a P material and N material nearby one, automatically the light energy is imposed to the power. It means that power side, it means in the space, this is in space between the channel. So from the channel we can get the light energy. This is the VA characteristics of an LED. Here the voltage increases, automatically the current is increases, depends upon the LED point, it is in starting point. Voltage increases, current increases. Thank you all.